Assalamu alaikum students. Now we are starting our next topic after this electricity. In the previous class we studied about electrical resistance, resistance of ohmic conductor and non-ohmic conductor like LDR, thermistor, etc. And in this video we will study about electric power, because electricity is also energy, and wherever there is a rate of energy transferred, it means power is involved. So in mechanics, you studied power as rate of doing work or rate of energy transferred. So same concept is applied here. Power again here is also rate of doing work or rate of electrical energy transferred. Like battery transfers chemical energy into electrical energy, and when charge flows through the bulb, so that electrical energy of the charge converts into kinetic energy, and that appears in the form of heat and light. So always all these energy conversions take time. So the rate at which energy is transferred from one form to another form is called electric power. So electric power is defined as what? It is equal to rate at which it transforms energy from electrical to some other form such as heat. Okay, it may be light, it may be sound also when we talk about speaker, or then that converts into sound energy also. So electrical power, energy transferred divided by time, same formula. Electric power is also measured in watt, because all forms of energy are measured in joule. Joule per second is watt. Okay, energy is joule, time in second. So 1 kilowatt is a bigger unit, that is 1000 watt, and 1 megawatt is even bigger unit, 1000 watt. Potential difference. Now here we will derive the relationship, how that formula P is equal to VI comes. Potential difference is equal to energy per charge. This we studied earlier in the video of EMF and potential difference. So V is the symbol for potential difference, W for energy or work done, because energy and work are equivalent. Okay, charge. So here we can have this W is equal to V into Q, and that W fits in this triangle here, V and Q. So W is equal to V into Q, or V is equal to W over Q, right? And Q is equal to W over V. You know one more formula, Q is equal to IT, and from this we get I is equal to Q upon T. Okay, that is current is a rate of flow of charge. So power, work done upon time, or energy upon time. For energy, we can write V into Q divided by time. So Q upon T here is current I. I is equal to Q upon T. So Q upon T is replaced with I. So that is how we get the formula of electrical power, V into I. So that triangle comes again, VI. When power is to be calculated, V, potential difference across the two terminals is known, and current flowing through the conductor is known. Then we can calculate power simply by multiplying these two quantities. In the same way, voltage can be calculated from this formula, power divided by current. Current can be calculated from this formula, P divided by V. Electrical power ratings. Here different appliances we use, they all have different power ratings. We use electric power, electrical iron, we use heater, refrigerator, motor. Different appliances, they use different power ratings. So here electric iron is shown. What is written in this question? 1650 to 1960 watt. This is the range. The power lies in between. The voltage rating is also mentioned, and the frequency. This frequency we will discuss later, but voltage and power you have studied now. So from this you can calculate the current which will be flowing through this electric iron when it is functioning. I is equal to power upon voltage. Okay, here there are some examples, the devices or appliances we use and their power rating. Torch, it's 1 watt, very small power. Efficient lamp, 11 watt usually. Average power is given here. Desktop computer, that is 300 watt. Hair dryer, 1000 watt or 1 kilowatt. Electric kettle, 2000 or 2 kilowatt. Electric shower, 5 kilowatt. So these are the appliances. You don't need to memorize, but this is estimated power. So one should have an idea how much power any appliance can use. Okay, so the rate at which it transfers energy from one form to another form. See, they all are energy converter: lamp, torch, computer, hair dryer, electric kettle, they all are shower, they all are energy converter. Now we will solve some question using the formula of power. Calculate the power of a bulb that uses 1800 joule of electrical energy in 90 seconds. So formula: electrical energy divided by time. So joule, so 20 watt. Calculate the energy used in joule by heater of power 3 kilowatt in 1 hour. So power 3 kilowatt means 3000 watt, time 1 hour. So electrical energy divided by time is the formula. So electrical energy, time goes there. So when we multiply this, 3 into 1. So watt is to be converted, a kilowatt is to be converted into watt, time is to be converted into second, and answer comes this. Okay, so this is converted into megajoule also, 10.8 megajoule if the decimal shifts from here to this, between 10 and 8. Okay, 10.8 megajoule. From here we can have one more unit. If you don't convert kilowatt and hour into watt and seconds, then 3 into 1 is 3. So there is another unit of energy, we call it kilowatt hour. Okay, so we will study more about this kilowatt hour. Kilowatt hour is also another unit of energy, and that is also used when your bill is made by the this electric supply corporation. So when the bill is prepared, they give energy in kilowatt hour. All appliances, their power and the time for which they are used, like a fan, 200 watt, and it is used for 4 hours. Okay, so you can calculate that energy. So for that purpose, we leave our energy in kilowatt and we leave time in hours, because sometimes we use for longer time. So second will give you very big number, large number, so many figures will be there in that. So to reduce the number of figures, number of digits, what do? We keep them in the bigger unit, like we keep the power in kilowatt and time in hour. Okay, so and then answer comes in kilowatt hour. Here, electrical energy used, power is to be calculated, time is given. So answers, let us see. 30 watts, 600 divided by 20 is 30, and power is given, time is given, energy can be calculated. So 75, I think, yes, 00 comes here. Time can also be calculated using this. Here power energy is in kilojoule and this is in minutes. And see, answer comes in watt, means you should have converted this 10 minutes into seconds. So you will multiply by 60. So it means 600 seconds, and kilojoule is to be converted into joule. Then answer will be in watt. Okay. Current into voltage, this we already derived. Electrical power is measured in watt, current in ampere, voltage in volts. Okay, now we will make use of this second formula of power. Calculate the current drawn by a kettle of power 2 kilowatt when connected to the mains 230 volt power supply. P is equal to V into I. So current is given, power is given, so we can calculate the current. Okay, I is equal to P divided by V. So 2 kilowatt divided by 230 volt. So power is to be converted into watt here. so that the answer comes in ampere. So this is kettle draws, see, large current, 8.7 ampere is quite large current. Okay, now you have to complete this. Here I and V multiply simply, see what comes, 1150 watt. Okay, here V and P are given, so this is the answer. In the same way, 12 fours are 48. Here current is in milliampere and voltage. So milliampere is to be converted into ampere. So it will be 0.2 because you will divide it by 1000. So let's see what comes, 1.2 watt. Let us have a look at this. Here electrical power we will talk about. Power in kilowatt. Power and energy. P is equal to V into I. Okay, and power is energy upon time. Vi and energy is equal to VIT. Okay, so energy is equal to VIT here, and if you know the time and voltage and current, you can calculate energy using this. So this is your power. So energy is power into time. Okay, so when you use any appliance for hours, like 2 hours, 3 hours, and the wattage is also big, like electric kettle, suppose 2 kilowatt, or motor 2 kilowatt, and this is used for, say, uh, you can say 2 hours, for example. So total is 4 kilowatt hour. Instead of writing power energy in joule, you can express energy in kilowatt hour. Kilowatt hour is the unit of energy. It is unit of energy. And we use this unit while calculating the bill. And using this, we can calculate the cost also of using any appliance. So when we use any appliance and the power is big, for example, wait a minute. We open another window. to I, and energy is equal to V I T. This is what we have studied. So how do we define kilowatt hour? Unit of energy. And how do we define? When 1 kilowatt power is used for 1 hour, the energy consumed is 1 kilowatt hour. Okay, so whenever you need to calculate the electricity bill or power energy used at home by so many appliances, like you have fan, heater, bulb, so and you need to know the duration, like for how long fan was used and for how long electrical heater was used, bulb was used. So you kilowatt hour you will calculate for each appliance, for fan, for heater, for bulb. Suppose you are using only these three appliances, okay, and you know the duration, you know the power, okay, like fan 200 watt, and time it is used is 6 hours, okay. Bulb, suppose 20 watt. Now if there are two bulbs you will multiply, okay, and suppose they are used for 5 hours. Heater, of course it has big power, suppose 3000 watt, it means 3 kilowatt, okay. So suppose it is used for 1 hour, so this you will convert into kilowatt, so it will become 0.2 kilowatt. This is 0.02 kilowatt, and this is 3 kilowatt, okay. You will calculate to energy of fan, energy of this, and energy of this. So that is how you can calculate the total kilowatt hour, okay. So more appliances can also be added in the same way. We can define we can get the relationship between kilowatt hour and joule. Energy is equal to kilowatt hour, okay. This is the unit and it is VIT. Convert kilowatt into watt. Kilowatt into watt to get the answer in joule. So this will be 1000 watt, okay. Now time into seconds. So 1 hour is equal to 3600 seconds. So into 3600. So what answer comes? 3600,000. Now second. So watt into second is joule, because energy is equal to power multiply time. So watt into second is joule. So you, what is an equivalent of 1 kilowatt hour? 36000 joule. Or you can call it, if you shift the decimal here, it is equal to 3.6 mega joule, okay. So this is equivalent of 1 kilowatt hour. So If you have to convert kilowatt hour answer into joule, you will multiply by this factor. Okay, if you have to convert joule into kilowatt hour, you will divide by this factor. One more thing, other forms of power. Electric power, let us have P is equal to V into I. Okay, so V, from Ohm's law, what do we know? V is equal to I into R. So I into R and this I. Okay, this has come from this. So I into I, that will become I square into R. So this is one more formula of power. So if you know the, because all resistors are also energy converter, okay, because they convert electrical energy into heat. So if you know the resistance value and you know the current flowing through it, you can calculate the electrical power also, like this. If I ask you to calculate the energy used up by this 100 ohms, suppose this is 20 volt and the current is, suppose this is also 100, so current is 0.1 ampere. 0.1 ampere current. So it means if I ask you to calculate power of R1, so what will you do? P1 is equal to I square into R. This formula you will use, zero point 0.1 square into 100. Okay, so zero point 0.1 square is 0.01 into 100, means 1 watt. Same power will be drawn by R2 because this is also same resistance. So total power is equal to 2 watt. Let us see how much power battery gives. Battery draws current of 0.1 ampere. So for the battery, we will use P is equal to VI. This is battery. Battery gives 20 volt and the current by battery is 0.1. So 2 watt. So total power given by battery is equal to total power used up by these two resistors. Okay. So beside having I square R, we have one more formula of power. What is that? See, P is equal to V into I, and you remember Ohm's law, V I R. So V is equal to I R and I is equal to V over R. In place of I can write V over R. So your formula of power now becomes P is equal to V square divided by R. So this is one more formula of power. Okay, suppose in a battery Battery gives again, uh, suppose 2 volt, 20 volt. Current is not known to you. This is one resistor, this is another resistor. Okay, and suppose potential difference across this is 12. Hmm, or this is 15 volt. This is 30 ohms. This is 10 ohm. Okay, so you can calculate electrical power using this formula. You know the voltage 15 volt, you know the resistance. So P1 is equal to 15 square divided by 30. Okay, so 15 square is I think 225 divided by 30. So let us check. 15 into 15 is equal to 25 divided by 30 is equal to 7.5 watt. Okay, and out of 20, this one must be having 5 volt because 15 are for this. So what is P2? We can calculate P2 by 5 square divided by 10. So answer comes 25 divided by 10. So this is 2.5 watt. 7.5 watt plus 2.5 watt. What is the total power? Seven point five plus 2.5. So that is equal to 10 watt. It means battery is also giving 10 watt because total power cannot exceed the power of the battery. So you can calculate the current. I is equal to P over V. 10 divided by 20. So the current through the appliance is, through the circuit is 0.5 ampere. Okay, so this current flows through this. So you can check also your answer satisfies this. 30 into 0.5 V is equal to I into R, 15 volt. Okay, so this is how we solve the questions of this electrical power. And of course we will do some more practice in the class, and we will inshallah have fun with this. Okay, so Allah Hafiz. Remember all these three formula of power: P is equal to VI, and P is equal to I square R, and V square over R. Any queries you have, you can ask me in the class, or you can post